define phase where we defined our problem. What is the problem? What the customer wants? What we are not able to deliver. In measure phase, we measured our current status, where we stand, did process mapping, and in analyze phase, we found out what are the causes by using some tools, different tools that are studied in our last two sessions. That is basic QC tools and improved QC tools, and also lean tools. After that, we have got, let us say, up till now, we have got around 10-15 causes which are affecting our performance or affecting the requirement by the customer. So, how to drill down in these 15 tools and get to the root cause? So, there are two types of methods that can be used. One is statistical tools, and second is the FMEA. So, statistical tools are correlation analysis, regression analysis, ANOVA, two-way ANOVA, control charts, design of experiments, hypothesis testing. Now, if you see, these are tools are very high level tools, and they require a lot of data. If there is no data with you, then it is difficult to use these tools in analysis. So I'm just going to give you an overview of this, what the tools do, and what are we going to do forward. But for FMEA, we will take a full session on FMEA. But now, if anybody is interested in having these tools in detail, we can have a session, special session sometime later after our all the pages of Six Sigma are over. Like this is the improve phase session, and then we have a control phase session probably next week or after that week. After that week, when we can find out how many people are interested in studying these practical tools, and then we'll conduct a presentation for them, wherein these tools I will touch in details with what are the tools, how they are used, and some examples. Today, to understand what these tools do. So the correlation analysis, regression analysis, all these tools are to understand the strength of relationship by using a Pearson coefficient. That is called a p-value. There is a software called Minitab, and Minitab 16 or 17 version is currently in use at different industries or institutes, wherein we put down the data, and we put the data in a format and then run this tool called correlation or ANOVA or hypothesis testing, and we get a typical chart showing the relationship between the X and the Y. Now, what is X here? X is the reasons or causes that you have found out in your brainstorm session. So it can be like we will say pizza delivery. So it can be due to bad weather condition, not good road, pizza not made properly, time taken for making pizza, all these things that are the excess or the causes that are causing your project. That is why. Why is the project always? So causing a project to not perform as per the requirement of the customer. So these tools are used to find out the relationship between the X and Y, the strong relationship, weak relationship, negative relationship, positive relationship, whatever the chart we throw up, and the relationship can be established. So the examples of these are cutting speed and tool life, moisture content and thread elongation, temperature and lipstick hardness, temperature and percent of foam in soft drinks, and all these things. So these relationships can be found by using this tool. And when we do a correlation analysis, and if you have say 5 or 6 causes for a single problem, then we can study them at one go, and we can get some charts which are different, and you have to analyze these charts to find out what is the relationship between the X and the Y. Sometimes we get a simple chart that is a line diagram. The method relationship of this is -1 is less than R is less than +1. -1 implies strong negative correlation, and +1 implies strong positive correlation. So how we find out the coefficient of correlation? We get, when you draw a baseline curve like this, so we get a relationship called y is equal to a plus bx. So where y is your tool, y is your effect or the problem statement, a is intercept, b is the slope of line, and x is the independent variable. So whenever we do correlation analysis, we'll get this type of result saying that this is this plus this into this, and y is equal to a plus bx. So after that, this we can find out which are the causes, or which are the problems, or which are the steps that are causing your problem to your project to get derailed or project not get perform as per the requirement. By using these tools, we can find out if you are around 10-15 causes, the sound data. These tools require data. We cannot use these tools by only using your experience and knowledge. Require strong data. And with data-driven processes, then we can establish the relationship between why and find out which are the causes that are affecting the uh, your performance, and then you can act on that cause and to resolve the problem. So these are the tools, statistical tools that are generally used. So what we'll do is because these tools require in-depth more data and more explanation. So if anybody interested in sharing these tools, we can keep a session. Like some people were asking for this tool session when we did the analyze phase part one. So just somebody can take up a call and come let me know if you're interested in these tools to studying in more detail. So we can have one session only on these tools. I can give you examples with how to be done, and Minitab also. I can share the Minitab files with you so that you are able to study this tool in more detail. So this is one of the way of finding out the root cause and act on the root cause. The second way is FMEA. FMEA is failure mode effect analysis or root cause or improvement phase, wherein what we do is use on our experience, use on some data, use on uh, the team. We find out what are the causes, what are the excess that are causing the performance to be down, and how to act upon it and how to improve it. So how this is done is always you know that y is the function of x1, x2, and xn. So x1, x2, xn are all the potential causes. By using the failure mode effect analysis or FMEA tool, we can drill down what are the vital causes. You can see the funnel is being shown here, and at the top there are a lot of pink color balls that are the potential causes or excess that are found during the brainstorming session using, if you can say, Fishbone analysis, Ishikawa diagram, or some other tools. You're finding out the causes. By putting a team together, you're finding out what is the cause that is affecting my problem, or that is affecting my project, or affecting my performance. So you get 10, 15, 20, 25, 100 causes. So you cannot work on all the causes because one is time consuming. Second is all causes are not important. Some may be of less importance, or some may not be the cause. Some may be just a idea thrown by the group. So you cannot work on all the causes, and that project will run for a long time. And the management is interested in computer project in short time because they want to improve performance. They want to show the customer that we have taken your complaint and we are improving it. So nobody will allow you to go on doing the project for 7 months, 8 months, 10 months, 1 year. No. So we have to complete the project in 4 to 6 months. And analyze and improve will take the maximum time of the project. Define and measure will take around only 15 days. The analysis you do and the improvement you do, that will take 1 month because you have to prove to the management that whatever the improvement is done is really effective and it has improved my project. Let us take a example of peer delivery. Now, what you say is the peer delivery must be done 30 minutes, and your current performance is that you are doing 45 minutes. When you find out the in analyze page, you found out 15, 20 causes, then you do the FMEA. And if you are working on 20 causes, it will take you know that the delivery can be 30, but improve all 20, 25 causes, it will take you 6 months. So you cannot wait for 6 months to show the customer that we have taken your complaint seriously. So you have to improve in 1 month. So you have to find out by using FME or using coordination tools or some statistical tools, what are the main 3 causes that are causing my late delivery. So once you find out that 2, 3 causes and act upon it, your cycle time or your delivery time comes down from 45 to say 35, not below 30, but still 35. So you are improved. So you can show the your customer, also the management, that the customer that before the project was taken, our delivery time 45 minutes. Now after doing the analysis, finding out the causes, doing data statistical analysis using FMEA tools, we have now acted upon 2 to 3 or say 4 main causes that are causing the delivery, and now we have acted upon these 4 main things and reduced our time from 45 to 35 minutes. So 35 minutes, so we are improved. Still not on target, but we are improved. Then you can shift to the next 4 causes and act on it. So this is how the projects work. You don't work on all the causes that are found in the brainstorm session. So please be clear on these issues, that you have to always work on some minimum causes. If you are doing many causes, it will take time, it will take more effort, more energy, and also more resources to work on all the causes. So you have to go stepwise, find out by doing a root cause analysis or by statistical tools. You find out what are the main 3, 4 vital causes that will give me a big change. By doing Pareto will also help you. that which are the main causes that are giving me a big change. But after FMEA, you can also use the Pareto on the FMEA numbers to get the which are the main causes that will bring me a big change. So what is FMEA now? What is the failure mode effect analysis? Developed in 1950s by aerospace industry, that is NASA. NASA developed this program for this developed this tool for the space program. They used to use this tool to find out what may go wrong. Now we are trying to find out what may go wrong in what is going wrong in my process. Now they used to do predictive analysis. What may go wrong? What may go wrong when I launch a satellite in the orbit? What may go wrong there? What may go wrong? Somebody is going in orbit. Some man is being sent to in space. So what may go wrong there? So that time they use develop this tool. Now it is widespreadly used in automotive industry, where they find out what is going wrong, what can be the causes of having a defect in the automobile or what in the process. So that is where FMEA is widely used. Now FMEA can be of 2-3 types. One is the equipment FMEA. The FMEA done on the equipment. What can go wrong in pump? What can go wrong in a compressor? What can go wrong in a heater? What can go wrong in a machine? Typical machine. So what is a typical equipment FMEA? Then we have process FMEA that generally we do in manufacturing sector. Process FMEA focuses on process and systems. What can go wrong in the process? That can be found in the process. That is a complex FMEAs. Then somebody do a design FMEA. When you are doing a design, okay, when you are doing a design, you can find out in the design stage only what can go wrong and how I can solve the issue at this stage only. That is called design FMEA. For doing my FMEA, again, you must find out what are the X's, that is X1, X2, X3, that is you have to find by using the fishbone diagram or Ishikawa diagram or any brainstorming session. Then FMEA inputs are detailed process map, fault tree method, cause and effect diagram, that is CNE matrix, control plan, customer requirements. Then you go to the FMEA, and what are the outputs of FMEA? Actions designed to prevent the failures. Historic data for improvement projects undertaken. Input to control plan. So what the FMEA outputs are? Action plan. What is the action plan on your causes? And what is the historic? It also gives a historical record. Because when you have FMEA done, it is a record, the document. Next time also if I refer to it, last time हमने FMEA किया था, तो उसका क्या था? What were the causes? What were acted upon? Now we are still getting some problems. So have we missed some causes? So again, you can refer FMEA done in the last session or in the last time, so you can take it forward. In process mapping, we already discussed this because it is a part of FMEA. I am again repeating this. What is the objective of process mapping is? Actual process or documented process, value added versus non-value added, inputs versus outputs, macro map, process flow diagram, detail map, and we all discuss. Now, brainstorming session is used to find out the C&D diagram, cause and effect diagram. So again, you will find out some of the tools are repeated here, but FMEA being a tool which will give end-to-end results. Generally, we also I am repeating these tools which are using. We already discussed in some other sessions. So brainstorming session is done, and you find out what is the cause and what is the effect. So always you must know what is the cause and effect. You cannot have a effect first and cause later. So always you must know that what is the cause and what is the effect. So effect is the brake stops and the cause is because I press the brake pedal. The car will not stop till I press the brake pedal, or it will have an accident. So accident is the effect of not pressing a brake pedal. So accident can be effect of or effect ka cause hoga, I didn't press the brake pedal. But if the car stops, then I must have applied the brakes to stop the car. So that is what we call the terms. What is the effect and what is the cause? The different terms of FMEA causes. Causes are sources of variation which are associated with key process inputs. Causes can be best defined as a deficiency in which results in a failure mode. So the causes are having a failure mode is due to a cause. Something doesn't fail on its own. There is a cause behind it. We all know when we are a technical engineer, so we know with every effect there is a cause. You cannot have effect without a cause. Effect is the impact of the cause. If it is impact on the customer. Now in our project stage, we can say the effect is the impact on the customer, that the failure is happening. Some failure happened which is having an effect on the customer, and there is a cause for the failure. So failure mode is in middle. Some cause happens, due to some cause a failure happens, and failure has the effect on the customer or the project. pizza delivery. The cause is you didn't get the raw material on time. So what is the failure mode? Failure mode is the pizza didn't get prepared on time. And what is the effect? The customer delivery is late. So the cause, failure mode, effect are the three terms that are used in the FME process. So we can find out the causes by using this brainstorm 6P and or 5M 1P diagram that we discussed in our cause and effect diagram. It is also called Ishikawa diagram. It is also called the fishbone analysis. It is the same thing. So this is an example of equipment failure. And so list of primary and secondary functions of each equipment. Power supply hai, dew boil regulator, field and control instruments, oil coolers, filters, transfer valves, piping, pumps. All these are the drivers, all the part of the equipment. Then establish what are the failure modes. The failure modes can be inadequate maintenance practices, inadequate operating practices. That is, maintenance is not doing PM properly, not doing PM maintenance on time, are the inadequate maintenance practices. Operation practices is doing some malfunctioning, not working, not opening the valve smoothly, or not running the equipment as per the required. There is a high ampere, then reduce the flow. All these things are operating practices. A material component failure, like failure in the wall, failure in the driver, that can be a material component. Design failure, that design is galat hai. The pump required here is of capacity of say 200 meter cube per hour, and they are putting a pump of 150 meter cube per hour. So you are not going to get the desired flow. That can be design failure. External failures like power supply. Power supply is not in your hand. It is coming from some outside agency. The external failure, power supply, or non-productive, like there is a flooding in the area. Due to heavy rains, there's a flooding, or due to heavy winds, water ingress is there in the area, and so they are non-preventable, or that is called mother nature, where we don't have control. The external and non-preventable are where we don't have control on these factors, or combination of our factors. It can be a combination of different factors. So this becomes starting point for good FMEA. Okay, so you can build a matrix of FMEA on system, saying that either the equipment is main oil pump, standby pump, duplex oil pump, oil filter, oil cooler. What are the functional failures? Loss of pressure, low pressure, high temperature, everything. Can go on writing the failure modes. Then what are the causes for low oil pressure? Are they maintenance causes? Are they operation causes? Are they design causes? Are they material causes? What are the causes are there? Then you can tabulate in this way. Say main oil pump, low oil pressure, cause due to operational task, cause due to maintenance task, due to material failures, or due to design inadequacy. So we then drill down a fishbone diagram saying what are the functional failures, maintenance, operation, and design and material. So operation task, we can write in high oil pressure that you can find out what are the console oil level low, transfer valve position in the wrong position, filter not clean, pump bypass left open, standby pump not kept on auto. All these things are operational, wherein there is operational control. A person from operation has to work on this, but he not work, so there is a failure. That is called operation task. In maintenance task, dump CV, wrong trimming, air vapor in oil. There is oil having a air lock, so oil is not flowing properly. Vent is plugged, so that the air is not able to remove. Pump RV passing, pump speed is low, standby pump does not start when required. All these things are maintenance. Because maintenance is not done properly, these are the causes which are affecting the pump performance. Then we have a design inadequacy. Line equipment sizing is not proper. Filter element is sizing not proper. So there is a filter in the pump which must be of some mesh, 40 mesh, 60 mesh, which is not properly used. The mesh is wrong. So a lot of dirt or it is entering, or the flow is not proper due to wrong mesh. And equipment sizing is not proper. Say pump a discharge line must be 8 inch, but you are given 6 inch design, so it is having a low flow. So all these things are design problems. And then we have compiling failure modes like cause due to operation, task filter not clean, cause due to maintenance. They are all tabulated in this table, all these modes. So a failure is caused by a triangle. That is severity, occurrence, and detection. Every failure will have these three effects. There will be a severity effect, there will be occurrence effect, and there will be detection, which is detection is the identifying of the failure. Severity is the impact, how strongly it's impacting the customer. And occurrence is how much times, how many times the failure is occurring. Now, this FMEA is done in a group where the person who is solving the problem is the facilitator. Like if you are a project leader for pizza delivery, then you call in the people that are in your process, like somebody from the marketing, somebody from the sales, somebody from the logistics, someone from, say, the kitchen department, and all these people all are assembled, and you tell them that there is a failure in our system. The pizza delivery is expected in 30 minutes and we are doing in 45 minutes. So we are here to find out what are the failures. So operation failures. Operation failures can be that you can say raw material is not available on time. The person is not trained to prepare the pizza properly. The equipment, that is the oven or something, is not working properly. Or water is not available. All these are operational failures. And somebody is working in, somebody is having a not properly trained person to make the pizza. That's operation failure. The maintenance failure. Oven is we have 6 ovens, but 4 are not working, so it is not maintained or not prepared. So there is a stress on the rest 2 ovens to deliver to make pizza fast. So it is having a queuing is a problem. The maintenance problem can be the water line is choked, so water is not flowing properly, or you have a power point, that is power connections available in your pizza kitchen, 6 connections, but out of these 3 are not working because they are failed or not repaired for this. So this is a maintenance failure. In your design failure, that somebody has know that there will be a Ratko 6 to 12 is the highest time where the pizza is highest orders of pizza are coming. So you must have 10 ovens, you must have 20 people working on it. All these things they are not properly done. Ovens पांच ही है, जो सुबह है वही रात को है. Number of people working in the daytime also same, night time also same. So all these are design failures. So if you have found out like these failures, which are operational, maintenance, design, all these failures. So let us say you have found out 20, 25 failures which are causing that late delivery of pizza. Then you have to rate or put an impact of what is the failure going to impact, severity of impact on the scale of 1 to 10. Then the probability of occurrence, how much time this occurs. Let us take example, there are 10 ovens out of which 6 are not working. So what is the severity? The severity is very high because it is going to put queuing. It is going to delay your pizza preparing process. So severity can be very high on 1 to 10 scale. Let us say 9 or 8, something like that. Occurrence is how much times in a month there is a problem of less ovens in service. So it can be once in a month, twice in a month, twice. Just rating for that. Detection. How fast you can detect that there is an oven not working? When you start the oven, or you already know it, or there's some other way that you can detect that oven is failed. Then that gives you detection. That is called the failure mode, and then you find out what is the severity, what is the occurrence, and what is the detection level. So the terminology used here are potential failure modes, a manner in which a potential process could fail. The effect of the failure mode, severity, and cause of the failure mode, occurrence of the cause, detection, and then you find the risk priority number. It's the product of severity, occurrence, and detection. It's S into O into D. That is the RPN number. And that is how we can rate. There's some potential failure modes. There are common potential failure modes that listed here for your reference. Air water leakage, brake failure, contamination, wall system, customer dissatisfaction, delay in delivery, excess interest, poor brake efficiency, oil carryover, inadequate service life, and so on and so forth. The examples of potential failures are bent, blister, bound, brittle, broken. These are the, you can see it starts with a verb sometimes. So the verb is actually a failure mode. Discolored, distorted, eccentric, grounded, leaking, melted, all these things are the potential failure modes. Then causes can be assembly error, damage part, handling damage, heat treatment, improper surface preparation, improper tool setup, material failure, misalignment, misoperation, out of tolerance, overheating, overcapacity. Just to discuss these things, these are all the potential failures that are having the problem. So how you rate the severity rating now? If you see here, we have ratings of 1 to 10. So if the rating or the effect is less, that is negligible, so you go on 1. and the rating effect is very high. That is hazardous. Now it is done in for this is used on safety issues. They can be we also have a rating for on the money part. So here on the money part, that is this rating is causing you damage to the business of how much rupees? 25,000 rupees or less, then it can be one. You're having 10 lakhs or say 1 crore or more, then it can be 10. So the higher the severity, high is the rating. That is the case. So what the failure mode is having a rating severity on the customer that you can define. The team will define. Your team, you can say some number, say 5, 6, 7, जो भी है, and that severity is to be rated on the scale of 1 to 10. The 10 being the highest or the most hazardous, most dangerous, most loss making, customer effect is more, and 1 being the lowest. Then we have occurrence. How is occurring? How much times the failure mode is occurring? Is one more than once in a day, you get 10. Once every 3 to 4 days, once in a week, once in a month, once in 3 months, once in 6 months, once in a year, and once in a lifetime. So that is 1 in 100 years. Once in lifetime is why 1 in lifetime? Because you cannot say that it will not happen only. आज नहीं हो रहा इसका मतलब कभी नहीं होगा ऐसा नहीं है, because the process is ongoing. So you cannot give a rating as it is nothing below 1. So 1 is the lowest rating and 10 is the highest rating. So the occurrence is more. If some failure is occurring daily, then you can give a rating like once in 3, 4 days, 9 or 10. If the failure mode is occurring once in a month or once in a week, then you can give a rating of say 7, 6, 7 or 8 like that. Then if you see your example of failure delivery, and somebody says there's a heavy traffic on this route, so it is causing the delay in delivery. So then if somebody can ask a question, how much time is the heavy traffic on this route? Once in a week, once in a day, every day? How much time? Somebody say नहीं every week होता है. Somebody नहीं every week कहाँ होता है रे? Last month में एक ही बार हुआ था. There can be some difference, but you have to create consensus of this, and always go for higher rating when you have a difference of opinion. Say somebody is saying 7 and somebody says 8, right? It is always advisable to put 8 so that you work on it. If you put 7 and the RPN numbers come down, you not work on it. And somebody sometimes that once in a month can shift to once in a week. In place like Mumbai or Delhi, heavy traffic is a concern for everybody. So it will surely be 8 or 9 on this heavy traffic potential mode. But in some places, say in smaller cities, the traffic may not be that concerned. So that can be once in a month or once in a week or sometimes once in 3 months also. So based on your experience, based on the team experience, based on the data, also have data. Na? If somebody is collecting data, how much times there are traffic in this area. So somebody must have data also, he'll keep data also. Somebody, you have to always believe in data. But if there is no data available, you can go on experience. But when you are working on experience, try to put the higher number so that you don't miss out some potential failure mode, which is really critical. So on severity, on occurrence, we found that 10 is always the number which is more severe or occurring more than once in a day, and 1 is the number which is less severe or is occurring less times. On detection scale, how detection is? Have you got detection like heavy traffic hai? How do you come to know before the person leaves the pizza delivery? Yes. If a person is going pizza delivery in some area, he can find on Google Maps that there is a traffic in this area on this route of some, say, going by this route. So you can change the route. You will still get late, but he may be late from the less late than whatever he is. Generally, we do these things. If you are going from, say, Ahmedabad to Baroda, so before starting, we take on Google Map. What is the route? What is the time shown? And we try to adjust our route by seeing the Google Map. That is called detection. That in that case, the failure mode is not reaching on time. So let us say we have to go from Ahmedabad to Baroda. And Baroda में कुछ शादी है, उसका मुहूर्त है शाम को 5 बजे का, and we have to reach by 5 o'clock there. So we find out on Google Map and say it is showing 3 hours. Oh no, we must start by 12 o'clock. Or it is showing 2 hours, so we can start by 2 o'clock. That is all these things we do. That is a detection that is do. That is also a failure mode. Not reaching wedding on time is a failure mode. What are the causes for that? One of the prime causes is traffic. The second cause can be the people are not ready, dress pehne ko time laga, or all these things. So car not starting. All these things are second day, or other they can less severe causes. The most severe causes traffics or heavy traffic or road diversions, some road work going on in some area which is causing this trouble. So what we do is when we start, we check on Google Map the detection. That detection we do. Detect the failure mode for, and prevent from happening. Once we detect, अरे ये तो ये बहुत जाम दिख रहा है ये area में. So let us find out alternate route. So Google also gives alternate route. So you again go on that one and check what is the difference. If the difference is only 5 minutes, you avoid. You try to go on the main highway. But if the difference is more, saying that highway is traffic jam, severe jam, and the next route is showing for 30-40 minutes faster, so we try to take the other route. So that is detection we do. And the detection in the industry practice, detection is how fast you can detect the failure from happening. Like if you can detect there is a failure of a pump has failed, and how can you detect the pump failure? Can you detect the pump by failure by seeing the data that the amperes are increasing, the current drawn is more, that is it is having some issue, or the flow delivery is slow, the flow is less, the pressure is not developing in the pump. That means the pump is having a problem. Can you trace? Can you see the charts? Can you see some data on the screen on the DCS and detect that there is some problem in the failure going to happen? So that is called a high detection. Or if you are not able to detect the failure mode, that is after the failure happens, then only you come to know that there is a problem, and it's a very low detection. So this time in detection case, when there is a low detection, your detection rate is going to be high, that is 10, because detection is low. Detection is low means the failure is certainly to happen before I come to know. That is called a low detection. And if your detection is high, that is if you have got the charts, you have got warning signals, we have got alarms which will show that the pump is moving towards failure, and the detection is high, detection is good, the controls are established, then it is called a good detection, and the rating is low or 1. So whenever there is a failure mode or failure mode is determined, we are doing FMEA for a project, we have got causes. For each cause there is a failure mode. Which failure mode you have to rate on severity of occurrence detection. It's called SOD. And do the multiplication of S into O into D. So if the RPN number or the risk priority number comes above 300, that is the product of S, O, and D comes above 300, or if there is a severity rating which is more than 7, then you have to take the control or action on the excess. So there are two ways of taking action. One is take the action by using a statistical analysis, so that you are more sure on the data, because FMEA data is used by FMEA, but data is in mind of people, and generally people's knowledge, experience, and some data taken by the team is used in FMEA. But when you move to statistical or graphical tools, then you need more data. So if the RPN number is more than 300, you take that excess to do more analysis on the excess by using the statistical tool, so that you are more sure on this. That yes, this is really a cause of concern, and you need to attend it. If the RPN number is less than 300 but more than 125, take immediate action on the excess. Then you can take simple actions. Like we just discussed Google Map. Then earlier what is there that somebody use Google Map, somebody else do Google Map. When you have delivery boys, you have 10 delivery boys going for taking a delivery to the customer. Out of 10, 3 are using Google Map, and rest are not using. They are just starting the bike and going. Traffic is there, they divert themselves here and there and reach the customer point. But then you can make it a point or make it in a control plan that everyone before starting from the pizza delivery shop, on pizza shop, will check the Google Map for the customer route, and then find out the best or the shortest route and use it. So that becomes your action. So that you can write down a SOP for that, or you can provide Google Maps to every individual delivery boys. Generally they have it, but somebody may not having it. So you have to make it a point that everybody uses Google Map while going for delivery. So that is a action or immediate action that you have taken to reduce the failure mode. That is how you take action on each and every failure mode. And then again to the FMEA. Remember, by only taking action, you're not going to get results. Take the action, wait for 7, 8, 10 days. Again do FMEA on the same action. Then you will come to know, are you really improving or not? Because once you take action, and if somebody is using that action and implementing the action, then only you will come to know that you are reducing the time or reducing the defect. So again, when you do FMEA, you again rate your severity, detection, and occurrence rating in this for this case, and find out what is the new RPN number after action is taken. So whenever you do the FMEA post actions, your severity rating will not come down. Always remember, your severity rating will always remain there. Simple. Again, the same example of your PR delivery. If somebody is using Google Maps and going for that ride, and still there is a traffic, heavy traffic somewhere which has taken place in between from starting office time, starting time to ending time. He started on the route, found that there is no traffic. Once he reached there, somewhere some accident happened and traffic has caused. So the delivery is going to be late. So your severity rating will always remain same. If you are given severity rating of 7 in the pre-FMEA or the pre-action time, and after post-action also your FMEA rating will be 7. Your occurrence and detection may come down. Detection will improve because now you are going Google Maps to every person. So 90% detection will improve. A person will come to know that there is a traffic in this area and I have to go by this way. So detection, if you are given a number of say 4, then it will come down to 1 or 2, and your occurrence will also come down because by looking at the Google Map and going, there is a chance that 70-80% times the pizza delivery will be on time. 1 or 2, 10% somewhere there is a last minute hiccup like accident or some conditions have gone bad and the road is jammed. But 70-80% or 90% of time your delivery will be proper because the person has taken the occurrence. So occurrence will also get reduced. Severity remains same because once there is an occurrence, then the severity is going to be a delivery late. So severity will remain same. The occurrence and detection values will improve. So your RPN number after action taken will come down. That is how the FMEA is done. There are some limitations in FMEA. Like you can see here, that the risk priority number is alone is not a guiding factor. Sometimes common sense, intuition, and logic is to be used with the RPN number. Like if you see here, failure mode A, severity of 10, occurrence 4, and detection 4 is having a RPN number of 160. While failure mode B is severity of 4, occurrence 10, and detection 5, RPN number 200. And in this time, in this way, you have to also take the severity in consideration. High RPN and high severity failure modes are to be addressed first. Because if the severity is too high, then a single failure is going to cause the business very much loss to the business. So you have to also consider the severity while doing the FMEA calculations. Generally, when we do the FMEA, we have got 25 causes. We'll add the failure mode, severity, occurrence, detection, and what is the RPN number. And top 4 or 5 causes are taken for taking the actions or improving that causes. So when you do these things and sort in descending order and take the top 4 or say 80%, you have 30 causes, 30% around 3 or 2 or 3 or 4 causes, let us say. Not more than 5 generally we take. So let us take top 4 causes. Then also you have to see the severity ratings of the rest of the causes. If any such cause which is having a less RPN number but severity is too high, and also consider take that cause for actions. So that is also a shortcoming of FMEA. But FMEA is very widely used in problem solving techniques. Very good tool. Many projects, starting many people use FMEA as a tool to solve their problems and issues. Very good tool, very easy to use, and very effective in solving your problems. So FMEA is a good tool to solve the problem. The control actions are of 2 types. What is the prevention and detection improvement? Because you cannot reduce severity. Always remember, let us take an other example. You are traveling on a motorcycle from say Mumbai to Pune. And then the FMEA failure mode is your bike will do accident. What is the cause of accident? Brake not applied, oil on the oil spill in the area, something like that, or potholes due to which you met with accident. And the severity is you're going to injure yourself, and if you are riding at the speed of 100, or say let us say 80, 100, then you are likely to have a big injury. Like you may have a fracture or some all these injuries can happen to you. So this is the severity. The severity rating is 8. Now the occurrence, say you will say the occurrence is 3, and detection is also 3. We have found out there is no potholes are there, but still you are driving carefully, still you get accident. Severity rating is 8. Your probability of occurrence is 3, and detection is 3. So your if a RPN number is 8 into 3 into 3, that is 72. So now you want to reduce the RPN number. So what you do is prevention. So what you will do to prevent? You will see that the brakes are proper. Before going on a long drive, you will check the bike properly. Brakes, lights, horn, all these things will check. So reduce the detection will improve, because if there is something brake problem, then you can adjust the brake, or you can tune the brake, whatever you want to tighten the brake, loosen the brake, all you can do. You can see if the horn is working properly or not, lights are proper or not. So detection you have improved. Then occurrence, you know that you check the road condition and try to navigate through properly the road, or reduce the speed, or you take other road which is having a less potholes, or a smoother road, or less traffic road. So by doing these things, you are reducing the probability of occurrence and improving the detection. But you are not going to reduce severity. The severity will always remain same. Also, if you met with the accident on a pothole road, then you are with the speed of 100, you are going to have a really good, not good, a bad injury. Also, you can use helmets, like wearing helmet during motorcycle. You will try to reduce severity. But generally, in a FMEA case, severity we don't reduce, because the effect on the customer will always be same when there is a failure happening. In some safety cases, the severity is reduced, because if you use helmet, use safety belt, or drive vehicle below 60 kilometers speed, then the severity may come down, because your impact will be lower. But in business cases wherein there is a loss of customer, loss of value, loss of business, or reducing your profits, the severity will remain same, because the failure is a failure. Only trying to reduce the probability of failure by improving the by reducing the occurrence and also improving the detection. So if the failure happens, it is going to cause the business the severity as it is. So after improving, or after putting the improvement also, the calculating the new RPN number, the severity rating doesn't come down. So developing FMES worksheets for equipment can be a consuming exercise. So what they do is, industries like automotive industry, or like tool making industry here. So वहाँ पे they generally keep the FMES handy when they are doing a process. So if you have FMES like a centrifugal pump, you have pump in the company. So pump के ऊपर FMEA, generic FMEA they will prepare, but it can be referred by anybody. Now, what are the generic failure modes of a pump? Low suction, high discharge, water current, more current drawn, less flow, low pressure, leak in oil not flowing to the seal area, oil seal leak. All these are wall close. All these are generic terms which can be applied to any pump. So what the industries do it, they prepare the generic FMEAs for reference. There is a pump failure, people will draw the FMEA from the library, digital library, and see if any of these causes are having their particular pump to fail. If there is there, then they already have got what actions to be taken, what is the severity, what is the action to be taken. So they can directly, you're doing FMEA, they can directly jump onto conclusions and take the actions to reduce the severity of the occurrence. So there are also FMEAs based on steam. If you have steam turbines, central compressors, you have heaters, which are common equipment in any chemical industry, bearing, seal, couplings, extension bellows. So these FMEAs, generic FMEAs are prepared, because FMEA takes time. You cannot prepare FMEA sitting on your laptop. You have to have a team. A team will involve around 5-6 persons from cross-function discipline, like something from maintenance, electrical maintenance, mechanical maintenance, somebody from process, somebody from technical services, all this. So these people have to invest their time, invest their energy and the resources. So FMEA is not a activity which is to be done very hastily or by a single person. It is always done by team. Here also in pizza delivery case, you have to put in a team of people from operations, from kitchen, from logistics, from order taking person hoga koi, from finance, all people you must involve which are relevant to your project. These people must come together and list down the causes, list down the effects of the cause, that is severity. And what are the failure modes? What is the cause? What is the severity of the cause? And what is detection available? What is the detection rating? Then what is the occurrence? How much it occurred in last 1 year? What is the occurrence scale 1 to 10? So all these things are very difficult, not difficult, but are time consuming, resource consuming, require a lot of effort, energy. Knowledge of the team is required. You cannot do FMEA by putting people which are new in the organization. They don't know what your process is. So you have to carefully do FMEA by forming a good team. So summing up, identify what can go wrong. That is failure description, causes, failure mode effects. Analyze how likely is the failure or what are the consequences, severity, occurrence, detection, risk priority number, SOD. One more thing, always remember that severity, occurrence, detection value cannot be 0. Any guess? Why the value cannot be 0? Severity, occurrence, and detection value is never 0. It is from 1 to 10. Why? Anybody? Okay, no issue. You always remember that the RPN number is the product of SOND, severity, occurrence, and detection. So if any of these value you put 0, the product is 0. So you have a failure mode wherein the severity is 10. Okay, and occurrence is 10. Detection is 0. So your value is 0. So your that number will go at the bottom of your table when you do in the descending order, which is never the case. And there is nothing called 0. There is nothing called 0 risk. So, and the risk priority number, it should always have a positive value. So SOD scales start from 1 to 10 and not 0 to 10. Always remember that. Then you do act what can be done, what can be eliminated, what can be changed, what can be reduced, and all these things. Then design solutions, test plans, SOP changes, error proofing. You can use the lean tools to improve your system, like Pokayoke is there, that is error proofing, which 5 years. Sometimes doing 5 also improves a lot of things. And you can prepare a control plan to find out what is what can be done and how we can reduce the improve detection, reduce the occurrence, and also try and improve the severity, reduce severity wherever possible. So once we do FMEA, we have got all these tools, statistical tools hai, ya phir FMEA hai. These are called prioritizing tools, where we prioritize which are the main causes that are affecting my product performance. So from say 100, we reduce down to say 2 or 5 causes, and then we show this, use it as a find out that 2 to 5 causes which are concerning us, which are having effect or a strong effect on the performance, and we then put up an action plan to improve this and improve our project. That is called the improve phase. So what we do in improve phase is we do the find out solutions, do a pilot, and then we implement it. So again we do FMEA and improve phase, because FMEA we saw after doing the actions, after taking the actions also, we again perform a new FMEA to find out what has come down, how much the number has come down, what is the improvement, is the improvement small or is a major improvement is there. So that is what we do in the major phase FMEA or improve phase FMEA. So solutions can be, again, brainstorming will only give solutions. No statistical tool or no tool like FMEA will give solution. Solution is to be found out by the team that is involved in doing the project. So they can be from quality, production, engineering, HR, finance, R&D, relevant areas. So you will say that theoretical tools मैंने use किया, correlation use किया, and I found that this X1 is the major issue. And if I fix X1, that is X1 cause X1 or cause X10, then my product is going to improve. But who will fix it? The person has to fix it. Your tool or your laptop will not give you what to be done. It will only show you what is or which is the cause that is causing the most effect. FMEA also do same thing. You know, FMEA आपको मिल गया कि top 4 causes मिल गया, top 4 failure modes are having a problem, and that top 4 if are improved, your performance is going to improve. But then who will improve? Who will be solution? The same team. You cannot expect a solution from the laptop that he will show you what to be done. They will only show you what are the top 5 or top 4 causes that are having effect on your performance, and you need to fix these 4 problems to improve performance. Then again, a team that has done the brainstorming for finding out the causes. The same team you have to assemble again to find out solution for these causes. So if the solution, let's say हमने discuss किया कि we have got a traffic jam solution for delivering pizza. Let you due to heavy traffic. Then the same team will suggest ways to improve this. You can use Google Map. You can ask the person to go by train. You can ask the person to go by metro. You can ask them to go by bike instead of car. All these things. There are solutions. Then again you have to rate the solution, which is the best solution. You have to find it from a team only. All these things are in the improve phase. Once you find out what are the solutions for the top 4 causes, you plan a pilot saying that we are going to change our working style by putting in these 3-4 new ideas. Then you list down the ideas. What are the ideas? What are then agree upon the team that we will implement this. Say 1, 2, 3, 4. The ideas we are going to implement. Then you have to train your staff on working in that new way, because you know it. Working करने वाले लोग तो staff ही है ना. You are not going to do work for everything. You are going to facilitate, or you will be working in some part. You are not going to work in all parts of all functions in your organization. So you have to convince the staff, convince your bosses, convince staff that by doing this 1, 2, 3, 4 new things, we will improve our production, improve our cycle time, improve our customer satisfaction. That is what we are going to do. So once you do in the improve phase, then you have to take the permission of your bosses, change the system and do a pilot for say 7 days, 8 days, 10 days, 15 days. For example, say 15 days of pizza delivery. आपने बोला कि we will have this 1, 2, 3, 4 new way of working, and this time I am confident that our pizza delivery time, which is 45 minutes now, will come down to around 30 minutes or below 40 minutes or below 35 minutes. Some conviction you have to tell, some confidence you have to give to your management. In that by doing these 3 things, we can reduce our pizza delivery time by 10 minutes, 5 minutes, जो भी है. The management will approve. Some will not approve. Some whatever they think, they will think what is the implications, financial implications है नया system. You also explain them. When you improve, you need some finance to put in some new things, or you need some manpower to improve the things. You need some equipment to improve things. So all these have to be stated in the improve plan, saying that these are the 4 steps you are going to do. This is the budget required, or this is the manpower required, this is the equipment required, and all these things. Once the management is approved, then you again call all the people who are working in all these functions, train them on the new system, give them the new SOP in writing. If you are going to change something, give them in writing, train them, and then declare that we are going to do this pilot from this day to this day, say 15 days. Then ask somebody to take data for the 15 days. You are doing the pilot. Somebody has to take data. What the time required? What is the production improved or not? Whatever may be the result. Then in that 15 days, you do the pilot, take data, wait 15 days. Don't hurry up. एक दिन उसमें fail हो गया तो don't hurry. अरे यार ये fail हो गया. Don't worry. When you are agreed, management has agreed that 15 days will give. You do the 15 days pilot. Unless until there is a severe issue. Unless until there is a severe issue, like safety issue है कुछ तो, yeah, there is a that is failing miserably, which is you think that is going beyond control, then only you stop the pilot, or unless by one day failure, don't get bowed down. If you're confident, please continually continue the pilot for 15 days. After 15 days, take data. Again, find out the mean, run the Six Sigma chart. Find out the mean, what is standard deviation, what is the variation, find out the sigma value. We did not. Upper limit and lower limit divided by standard deviation. Has the sigma improved? Yes. What has the mean improved? Yes. No. जो भी है. If it is working, let's say that PR delivery आपका 45 days था, 45 minutes था. Let's come down to 36 minutes now. The mean. Don't go on the mean. Find the variation and find the sigma value. आपका अगर पहले sigma 0.01 था, not the sigma is 1, but it is improved. When you show your bosses that, sir, by doing this 25 things, we could improve our player delivery time from 45 minutes, that cycle is reduced from 45 minutes to now 36 minutes. We are 30 minutes we are counted to the customer, but still we are above by 6 minutes, but still we are improved by 9 minutes. The man will be happy. Then that solution is now taken in control phase. That is what we see, that it is improved now and it worked for 15 days or let's say 1 month. Then you say that this solution is correct. By doing this solution, we have achieved our result of improving the cycle time, reducing the delivery time by 9 minutes, which will improve our customer satisfaction, which will give us more customer, which will improve our business. That is how a improve phase is done. So that is the improve phase design. So again, you will find this same thing at y function of x1, x2, x3, xn. Out of this xn, by using these are excess, that is called a potential excess, maybe 25, 30, 40, by using some tools. It can be FMEA, prioritization matrix होगा, आपका Pareto होगा, statistical tools होगा. Using these tools, you find out what are the vital 4 or 5 causes that are derailing my project, derailing my performance. Act on them. Prepare an implementation plan. Prepare a pilot plan. Show it to your management. Ask for the resources as required. If there is no resource required, well and good. Sometimes required, then you have to take the resources. Plan it for 15 days. Train the staff working on the plan, on the new plan, new changes, new steps. There is a new steps you introduce to reduce the things. So you have to train them properly. Work, implement the plan 15 days. Monitor the 15 days. You have to monitor, as a leader, you have to monitor the steps. Don't monitor the why. Okay. Don't monitor what is happening to the why. Let somebody take data. Only monitor the steps, that new improved steps से लोग follow कर रहे हैं कि नहीं कर रहे हैं. Are they diverting? Are they again going back to the old step? Because people are working in this environment for last 2 years, 3 years, and they must be from the steps they are doing. So you have to change the steps. You have to always monitor that the people are doing the right steps. When after 15 days, again collect data. 15 days, 1 month, जो भी आपका decide होगा, time होगा. Again collect data, analyze data, find out what is improved. How is the improvement shown statistically? Sigma आपका improve हुआ है, cycle time आपको reduce हुआ है, variation कम हुआ है, जो भी है, show on data, show what was earlier, what is later. Then by doing this, and then discuss and deliver that the project is done, it is implemented. Then we move to control phase, that we will see next time how a control is taken and how you can sustain the improvement. So this is the improve plan. This is how you put the improvement plan. What is the solution? What is the sigma? What is the time? And other things. And what is the score? So thank you. Now, if any questions, we can take the questions. And also, I want to know if anybody is interested in seeing the tools